Okay, if you look at this, we're going to do some examples of stuff that you saw in your lab. In that paper, you're going to have to do this with your own data, but I'm going to walk you through some made-up data, which I did. Now, as I am looking at this, what you should actually have are these middle two columns right here. You should have an initial mass and a final mass. You do not know the sucrose concentration, but you should know a color, correct? So you should be associating a color. I'm telling you right now that your colors are going with these concentrations. Okay? So, the one that gained the most mass of your potato cores should be what? Okay? Right here, 0. 0 should have gained the most mass. The one that should have gained the least mass, or actually, if it was losing mass, should be the 1 molar concentration. So just remember when you go through that you can order them 0, 0.2, 0.4, 0.6, 0.8, and 1.0. Now, as I'm looking at this, I turn these into percentages. Okay? The percent change. So once I've done that, I came up with these percentages, and I am going to create a graph that goes with these percentages. Now, what did I name my graph? What did I name my graph? I named my graph, I put the title, the percent change in mass of potato cores in sucrose solutions of various molarities. Okay? It is very descriptive, I know, and that's what your title should be. Okay? So, notice I didn't say percent change in glucose solutions. Now, it was very, very descriptive. Percent change of mass in the potato cores in sucrose solutions of various concentrations. Now, what I'm going to do is I'm going to chart my concentrations on the bottom. So I'm going to move this a little bit. You know, you've got the title, I'm sorry. We're going to make it so you can't see it, but you know what the title is. So just give me a little bit here. Come on, Lord. Alright, so what I'm going to do is I'm going to put my molarities down at the bottom. There's 1.0, here is 0. Okay, so what's this? 0.2. 0.4. Like it. Like my lines here, because they're not gridded in darker. So I gridded in my, excuse me, my molarities down at the bottom. Now my percent increases. I need to have, the low end has to be able to get somewhere near the 43. So what I did just to make it easy is I said that this was 0, this was going to be plus 50%, so this would be minus 50. So, as I do that, let's see how many. I went off of every 5. So, 1, 2, 3, 4, 5, that was 10, 20, 30, 40, then to 50, then same thing down. So now what I'm doing is I'm going to come through and I am going to measure out. I'm going to measure out and put dots onto my chart of at 0%, what did we have? 10%, correct? So right here, putting a dot. It's not a very good dot, can't see it very good, but hey, okay. So, then at point 2, I had 6.67. So 2, 4, 6.67, somewhere around here. Now my next one was negative 6.67. So here's 0.4, here's 0. So I go -2, -4, -6, -6.67 right there. At 0.6, I was at 23.3, so there's 22, 23, somewhere around in here. At 0.8, I was at 30. And at 1.0, I was at 43. 40. Somewhere in there. Now, you've created this graph now. If you're dotting just like I am, which you should be making this so that we can go through and you have an example. But once I've done this, I need to get my best fit line. Now this is going to be tough for me to do because I do not have a ruler that I can put on my smartboard. Okay? I don't think it'll work. Maybe it will. I need a meter stick. Maybe it'll work. I don't know. We'll see. Last time I tried this and it didn't work. But it seems to me like it might work. So I'm going to make the best fit line. Yep, it's not going to work. So, now look what I've done. Let's just add the best fit line. Oh, that's perfect. Now, the reason I have a best fit line is why? Why did I make the best fit line here? What am I trying to figure out? Huh? Well, if I look at this, look at the back of that. It says on the back, number 8. Okay? Determine the molar concentration of the potato cores. This would be the sucrose molarity in which the mass of the potato cores did not change. To find this, draw the line, draw the straight line on your graph that best fits your data, your best point line that I just fit on there. The point at which the line crosses the x-axis represents the molar concentration of sucrose with a water potential that is equal to the potato tissue water potential. At this concentration, there was no net gain or net loss of water, so it was isotonic. Now, where does that happen at? Right there, isn't it? Where the line hits 0. So that is where the potato core and the sucrose concentration was identical. So if I look up and come down, what's that going to be? .26? Does that make sense? Am I reading my graph right from up here? Yeah? All right. So now my potato core, I've got my concentration of sucrose in those potato cores. It was 0.26. Now, on number 9 there, it says calculate the solute potential for the sucrose solution. Okay. So I got here my concentration to be 0.26, right? Molar. So what is the solute potential? Okay. Well, I is the ionization constant. If you remember in chemistry, do you remember Van Hoff's factor when we were doing, let's see, what is it, colligative properties? Okay. This is a covalent material. So it will not dissociate in water, so the ionization constant is 1. So I right here is 1. C is the molar sucrose concentration at equilibrium. What did we just say that that was? C is equal to 0.26 molar. The pressure constant. Now, believe it or not, the pressure constant is always the same because it is a constant. So the pressure constant for this is 0.0831 liters times bar over mole degrees Kelvin. Now the only other thing that we need is the temperature. And let's say that the temperature was 22 degrees Celsius, because that's somewhere pretty close to what room temperature is. So I'm going to take 273 plus 22, that gives me what, 295? So when I do my mass of my solute potential, which this is this little solute, that's a little s, my solute potential, it's going to be negative 1 times 0.26 times the constant 0.831 times 295 degrees Celsius, excuse me, that's Kelvin, not Celsius, so that's not degree, Kelvin. Okay, so if I look at this, and I say, okay, when I come up with my value and do my math, I come up with a value of negative 6.37, and my label is going to be bar because that is what does not cancel, because we know that molarity is a mole over a liter, and I have a temperature, so I'm left with bar So that is how I calculate the solute potential. Now, I believe that you are going to need to be able to do something like this when you are evaluated for this lab. Okay? So I would make sure you run through this process with your data as a kind of test, because you will have some more of these, another one of these given to you with my data that you will have to do. Okay?